6a, it says to find when the particle is moving to the left, so we want to talk about when the velocity we want to talk about when the velocity is less than 0, and so when I set cosine of pi over 6t equal to 0, I know that pi over 6t is going to equal 0 at pi over 2, and also 3 pi over 2. And so when I solve that for pi over 6, or I'm sorry, for t, you'll have pi over 2 times 6 over pi, which is equal to 3. And then you'll have 3 pi over 2 times 6 over pi, which is equal to 9. And if I think about the general cosine graph, I know that it looks something like that. And there's not any kind of flip or anything. So the pi over 6 is just stretching the graph out or shrinking it up, however you want to look at it. So I know that velocity is going to negative between those values of 3 and 9. So that's why our answer is between 3 and 9. And so you can see that you get a point for just recognizing that you're looking for when the velocity is equal to 0. So make sure you're showing that you're setting your velocity equal to 0. And then also you get a point for having the correct interval. So let's look at B. In part B, let's erase some of this work over here. Okay. So in part B, it's asking to set up an integral expression that gives total distance. This is important here. Total distance traveled by the particle from 0 to 6. So it was not good enough to just say 0 to 6 of v of t dt. You had to make sure that you put your absolute value brackets around that because it was total distance. If you didn't, you just found net distance, and that was explicitly what they did not want you to find. So you can see you just get a point there for the answer. If your limits aren't correct in that problem or anything, they will not give you the points. And also don't forget your dt. And then in part C, it is saying to find the acceleration. So obviously you're needing to look for the derivative, and it's just saying at time t, so you know that your acceleration would be the derivative of the velocity, and in that case the derivative of cosine is negative sine of pi over 6 times t. Don't forget to chain on your pi over 6, and so when you clean that up, you'll have negative pi over 6 times the sine of pi over 6 t. So that's the first part. You can see that you get a point just for that. And then you also are asked to find, is the speed increasing, decreasing, or neither at t equals 4. If you remember, speed is the absolute value of the velocity. So you could look at your velocity function, which we already know what that cosine of pi over t looks like. It crossed at 3 and at 9, and we realize it's going to look something like that. And speed is the absolute value, so let's make that a different color. Our absolute value would look something like that. This would hump up like so, and then this would look something like that. And you can see that at 4, which is right around here, our speed is increasing because our velocity is positive in that realm. Another way to look at it, if you remember back from a concept we talked about, your speed is increasing wherever your acceleration and your velocity are the same sign. So if I could find a of 4, which would be negative pi over 6 times the sine of pi over 6 times 4, and when I clean that up, that'll give me negative pi over 6 times the sine, and that would be 2 pi over 3. If I think about what quadrant 2 pi over 3 is, we are in quadrant 2, and sine is positive in quadrant 2 times a negative, so you know that a of 4 is less than 0. The other thing you can realize is that when you're finding velocity at 4, that would be the cosine of pi over 6 times 4. So that would be the cosine of 2 pi over 3. We're in quadrant 2 still, and cosine in quadrant 2 is negative, so that would be less than 0. So since a of 4 and v of 4 are both negative, then we can assume that your speed is increasing because you have the same sign. So you can see you get 2 points for your conclusion with your reasoning. You have to put a statement here. You could have either said the speed is increasing at t equals 4 because velocity and acceleration have the same sign. You could have also said that the speed is increasing at t equals 4 because the absolute value of the velocity graph is positive, which is what speed is. And lastly, part D, it said find the position of the particle at t equals 4. If you remember from the beginning of the problem, they told us, let's go to a different color here, and also maybe make my a little thicker. They told us that they gave us our velocity graph, and they also told us that x was equal to negative 2 when t was equal to 0. So when I set up my x of t function, I will set it up as negative 2 plus the integral from 0 to t of v of, we'll go x dx, okay? Using the fundamental theorem of calculus with these two guys. So I will have x of 4 being negative 2 plus the integral from 0 to 4 of v of x dx. V of x, they already told us, was the cosine of pi over 6 times t dt. And so when I'm finding an antiderivative for that, I'm going to have to use u du substitution. In my problem, I'm going to make my u pi over 6 t. So my du is just going to be pi over 6 dt, which means I need a pi over 6 in here, which means I need a 6 over pi out front. Okay? So I have negative 2 plus 6 over pi times the integral from 0 to 4 of the cosine of u du. And then at this point, cosine's antiderivative is sine. And I'm going to go ahead and insert back in my pi over 6 t. And when you evaluate that from 0 to 4, don't forget we have our 6 over pi hanging out front, and we have our negative 2 added to the front as well. So we have negative 2 plus 6 over pi times the sine. When I put 4 in, I'll get 2 pi over 3 minus the sine of 0. Sine of 0 is 0. Sine of 2 pi over 3 is the square root of 3 over 2. I'm going to multiply that times 6 over pi plus my negative 2. Negative 2 plus, and then my 6 and my 2 can reduce to be 3 and 1. So I have 3 square root of 3 all over pi. And there's our answer. So we get a point here for the correct antiderivative. Alright, correct antiderivative being there. So if you have that guy, you got a point. You got a point for at least evaluating it at the initial condition. So if you would have used that fundamental theorem and did your negative 2 and your 0 right there, you got a point for that, and then you got a point for the correct answer.